You there with BGP? Yeah, you know me. You there with BGP? Yeah, you know me. My friend, in this nugget, we're going to enable the gold standard of internet routing, Border Gateway Protocol. And we can do so on both our edge service gateway devices connected up to the ISP, and we can also support it in the interior using distributed logical routers. I'm looking forward to doing it together with you in this hands-on lab. So to get our hands dirty with BGP, we're going to log on to the VMware Hands-On Labs, HOL 1903, the Getting Started lab, fire up Google Chrome, log on as administrator at vsphere.local. Once we're logged on, we'll go ahead and click the home button up at the top and make our way down to networking and security, of course. In the navigator, let's go ahead and select NSX edges. We can see our two devices, one being a perimeter gateway, an NSX edge device, the other one being a distributed logical router. Let's select the NSX edge, double-click that to delve into the depths of its configuration. And to add support for BGP, we're going to head over to the Manage tab. And what we're wanting to manage is routing support. So let's head over to routing as its subsetting. The first thing to ensure we have is a router ID. Any router supporting OSPF or BGP needs a router ID, which is typically assigned based upon one of the IP addresses associated with an interface. We can see that's already been configured ahead of time here on 192.168.100.3. We can also see that BGP is already started. Let's take a look at that BGP configuration. We can see that the BGP service is listed as started and that we're using the local autonomous system value of 65,001. We see the option for graceful restart has been started, and that means that even when BGP is going through a process of reconfiguration, it's still willing to forward on the data plane based upon the routing table it already has. And default originated is stopped, which means we do not promote ourselves automatically as a default gateway to interior BGP devices. And then we have added a neighbor. Unlike OSPF, which dynamically discovers neighbors, BGP requires that we manually configure pointers to neighbors based upon their autonomous system number and IP address. Anytime there's communication between an autonomous system and a neighbor that's using a different autonomous system, as we see down here, a connection to 192.168.100.1 at autonomous 65,002, that's when we're using external BGP. And that's exactly how routing is done on the internet, is with external BGP. Now, before we do any other configuration, let's go enable BGP on our distributed logical router. So we'll go ahead and click the home button and head down to networking and security. And let's crack open NSX edges and specifically Edge 3, our logical router. For this device, we need to make sure we're looking at the routing tab. And let's start with the global configuration. The very first thing we need is some sort of router ID. So let's go ahead and click Edit in the dynamic routing configuration. And from the drop-down menu, we can see we can add the transit network because it supports uplink IDs automatically as router IDs, or we could add a custom ID. For example, we could enter in 2.2.2.2. This 32-bit value is never used for routing. It is only used as a way to identify this particular router versus other routers when looking at configuration tables. Let's click OK, and we can publish those changes. In order to start supporting BGP on this router, we're going to go ahead and click BGP on the left-hand side, and we're going to go to the Edit button up at the top to initialize our configuration. First check mark is there to enable BGP, pretty straightforward. We can enable a graceful restart, which maintains the forwarding state even during the restart of the BGP process. The router continues to route even when BGP's service restarts. It doesn't lose the route when that happens. If you're wondering, when would I ever want to not have a graceful restart? It's actually something we have to turn off when we're going through an upgrade process of NSX routers. You'll notice that there's no default route originate here even available, and that's because as a DLR, we are the end of the road, not a place where we would expect a default route to come from. Down at the bottom, we need to define the local autonomous system number. What is the contextual identity of this router and all the routes that it might support? And that's going to be 65,001. Then we'll click OK. When the autonomous system numbers are the same as they are between the DLR and our Edge Services Gateway, we're going to be using what's called interior BGP instead of exterior BGP. Once again, let's go ahead and click Publish Changes at the top. Now that we've got our core BGP configuration in place, we can add neighbors. And we know we have a neighbor that is potentially available at 192.168.5.1. That's our Edge Services Gateway. Whereas this device, our distributed logical router, is currently running on 192.168.5.2 when it comes to that transit network that supports the connection between the two of them. So now we're ready to add our neighbor of the Edge Services Gateway. So we'll click the green plus to add a new neighbor. And the first thing we need to do is select the IP address that we're connecting to and the IP address that'll be the uplink address that we're connecting from. Right? How do these two routers talk to each other to share BGP information? And we can use the drop-down menu to make this a little easier and select the interface of the transit network, and it'll pre-populate it with the forwarding address assigned to that interface. And then we can indicate the IP address that we're connecting to is 192.168.5.1. That's the Edge Services Gateway. But then we need a protocol address. We're adding a new IP address here. And the reason why is because the forwarding address is being used here on the data plane. This is going to be how each ESXi host that holds its own copy of the distributed logical router can forward frames to the Edge Services Gateway, which it knows exists because of the shared protocol of BGP. But the BGP communication doesn't happen directly between the Edge Services Gateway router and each and every ESXi host. Remember, to support dynamic routing protocols, what do we need to have? A control VM. And that control VM needs its own protocol IP address that is going to be used to support communication with the Edge Services Gateway. And so that's what we're assigning here, is the control plane IP address that will be used by the control VM. We do not have to configure this as a separate IP address somewhere in the interface configuration. We just type it in right here, and that's what it will use. So we'll use 192.168.5.3. It just has to be within the same subnet as our forwarding address. For the remote autonomous system, we need to know what autonomous system 5.1 is using, because if it doesn't match, it will fail to connect. So we're going to put in 65,001. We can leave the wait, keep alive, and hold down times for their defaults for now. And those are values that determine priorities when we're looking at wait and we get a route from more than one source, as well as the keep alive and hold down time, which determine how long it takes for a route to essentially be pulled out of the routing table, because I haven't heard from my neighbor in a while. We could add a password, but we're going to leave it blank for now. And of course, we can add BGP filters, which can choose what information we actually are willing to accept or share with our BGP neighbor. For now, we'll leave all that blank and click OK. Then we can publish our changes. But now that we know that we're coming from 192.168.5.3 as our protocol address, we need to configure our Edge Services Gateway to use us as a neighbor. So let's go back up to Home, down to Networking and Security, over to NSX Edges, open up the NSX Edge, Edge 1, make sure we're managing routing, select BGP on the left-hand side, and then click the green plus to add a neighbor. Because this is not a DLR, the configuration is actually a little bit simpler. Who's the neighbor? 192.168.5.3. Remember, when you're pointing to a DLR as a neighbor, you need to point to the protocol address, not the forwarding address. It'll learn the forwarding address when they communicate. The protocol address is how it communicates. And the remote autonomous system number at 5.3 is 65,001. The wait, keep alive, and hold down times are the same. Passwords left blank, filters are off. Now we can click OK. Let's publish our changes. So the Edge Services Gateway gets a little smarter. And let's see if our routers have learned anything. Let's go over to VMs and templates. Let's expand region A1. Let's log in to distributed router 1. With the distributed router selected, we'll go ahead and click on the thumbnail to log in. Spacebar if we need to wake it up, and then we'll log in as admin with a password of VMware1 exclamation point, VMware1 exclamation point. And then the command in the CLI to be able to view the current routing table is show IP route. And sure enough, we see over here on the left-hand side a bunch of BGP sourced routes. We have a gateway of last resort, a default gateway for this router to forward all unknown packets, and then a bunch of specific routes to be able to get to the 10, 20, 30, 60, and 70 networks. Then we have one more down at the bottom to be able to get to the 192.168.100 network. Perfect. So we definitely have a relationship between our distributed logical router and our Edge Services Gateway, because otherwise we never could have learned this information. Now let's go back to the vSphere web client and let's select the perimeter gateway, and we'll click the thumbnail and log on in the same way here. Let's do a show IP route in this locale. And our information here is a little different. We can see we are getting BGP information from 192.168.100.1. If we think about the continuum of our ISP router connected down to our Edge Services Gateway, connected down to our DLR, the reason why there's a default route propagated down to all of them with BGP is because default route originate was enabled at the ISP level and then works its way down to all subsequent routers that allow for it. When we looked at the distributed logical router, we saw in the routing table that there was information that had come from the Edge Services Gateway with that B prefix that indicated, yes, this is BGP information. But here, looking on the Edge Services Gateway, we don't see any information coming the other direction. And if that's the case, that means we don't have bidirectional routing. The DLR is connected to networks 172.16.80.0 and 172.16.90.0, and there are no routes for those up here on the Edge Services Gateway. Let's see if we can figure out why that's the case and correct that issue. We'll go back to the Web Services client, and let's navigate back to our Edge Services Gateways under Networking and Security. Then on the left-hand side, NSX Edges. Let's select Edge 1, the NSX Edge, double-click on that, and head over to Routing. At the global configuration level, we can see our router ID is set up, BGP is started. If we go down to BGP itself, we see it's started, local AS, graceful restart. Default originate is not enabled here, but it does propagate the default route that it learned from the ISP. And then we have our two neighboring routers. The key here is actually going to be found under route redistribution. It's in this location that we can see that we, in fact, are willing to redistribute information into BGP. And specifically, down at the bottom under the route redistribution table, we can see that we're willing to redistribute information that came from connected routes. This is how the BGP database is going to be initially populated on this router with a list of connected routes that it's then willing to share with its other BGP neighbors. And if we want our DLR to be able to do the same thing, then we're going to need to configure an equivalent setting. Let's click the back button until we're looking at our list of Edge devices. And let's delve into Edge 3, the logical router. Let's make sure we're looking at route redistribution, which on this device is already configured for OSPF to inject information into the OSPF database, but BGP is not enabled yet. So let's click the Edit button on the right-hand side. So we'll just start with a check mark in BGP and click OK. And then down at the bottom under the route redistribution table, we'll click the green plus there. And from the drop-down menu, let's select BGP and indicate that we allow learning from connected routes, and leave it with the default action of permit. Then we'll click OK. Let's publish those changes, which immediately updates the control VM with the information necessary to now start speaking BGP correctly to other devices. And now let's take a look at the perimeter gateway tab that we already have open, and we can just up arrow and show the IP route again. And take a look, my friend. We have a couple of new routes, 80 and 90, now learned, which are available to route via 5.2. Why is it not 5.3? Remember, 5.2 is the forwarding address. That's the ESXi DLR address. 5.3 was the control information. That's where the information came from. And if you want to see some more information about BGP, here at the CLI, we can type in show IP BGP and press enter. And here it displays the information in the BGP table, which includes the locally sourced connected routes. Those all have a next hop of 0.0.0.0, and the adjacent routers that are either within the same autonomous system, or as we see with the default gateway, come from a different autonomous system, in this case 65,002. When we're troubleshooting information about BGP regarding neighbors, we can type in show IP BGP neighbors and press enter. And here at the top, we see, there it is, the BGP neighbor of 192.168.5.3. There's that control VM IP address with its autonomous system. It's currently up. That's a good thing. We see our hold and keep alive intervals that are configured. We can see the number of messages that have occurred. And if you're not getting the information that you're expecting, one of the things to look for is going to be, well, what did I even receive or send to that particular device? And if these numbers are not what you were expecting, then you might want to look at filters that might be blocking that, and redistribution, which determines what you're initially injecting into the BGP database and therefore are sharing with other neighboring BGP router. Down at the bottom, we see our BGP neighbor 192.168.100.1. You can press spacebar, and we can see that from that device we received one route, our default gateway, but we advertised 9. And down at the bottom, we have our connection between our local and remote hosts, identifying the IP addresses that were used and the ports that were used. Port 179 is used by one of the two devices to function as a server, and then we have an ephemeral port that is used on the other side to function as a client. So they establish a client-server TCP relationship. And in this example, this Edge Services Gateway, as it's connecting up to the ISP, the server is on the local port side. So we're functioning as the server in this case, and the ISP is functioning as the client. But as we connect down to the distributed logical router, The remote port is 179. That means that for that relationship, the DLR is functioning as the server and the Edge Services Gateway is functioning as the client. As long as we don't have a situation where both devices are trying to function as a server, we won't have any issues. My friend, by going through this nugget, you just successfully configured BGP on both your distributed logical router and your Edge Services Gateway. I hope this has been informative for you, and I'd like to thank you for viewing.